Alright, so I'm going to record this in the idea that we haven't done all this work here. So let's erase in a nice erasing mode. And we're going to come back to the statement of the problem. And we're going to do this using a p-value now. Again, they're conceptually p-values and the critical value that we compare the test score are. It's really the same thing. You know, the visualization behind it's just slightly different. I like visualizing the critical value and the z-score versus visually, but p-values are very, very useful. They, in their own right, can make a statement about the strength of your data towards a claim without comparing it to a significance level. Right, then, comparing the significance level, you can do, you can look at your p-value, you can say, hey, I got 0.000001, and so I could say this is good to a significance level of, you know, 0.0003. You can, the p-value becomes a statement in its own right about the strength of the evidence towards a claim. So you'll find that in the world outside of a textbook, p-values get quoted a lot, sometimes without full attention to what they mean. Conceptually, I think the critical value and seeing if you fall within a rejection region or a fail to reject region conceptually gives you more information. And since we're learning, those concepts are important. But I'm gonna do this with a p-value. So a researcher claims that less than 45% of U.S. adults use passwords that are less secure because complicated ones are hard to remember. So the claim we have is that our proportion is less than 45%. In a random sample of 100 adults, 41% say they use passwords that are less secure because complicated ones are too hard to remember. At an alpha of 0.01, is there enough evidence to support the claim? So let's bring this over here and let's get some things together for us here. Let's see. So our claim is, this is claimed by the researcher, that the percentage of adults is less than 45%. So I'll label this as a claim. I will note it's a less than, it doesn't have equal, so that is my alternative hypothesis. I will make my null hypothesis be the complete complement of this. And I have now covered all possible outcomes, so I can test my claim. And what we're going to do is we're going to generate a p-value and compare that p-value to alpha. And the thing we need to do in calculating our p-value is recognize that it's a left-tailed test. And being a left-tailed test, the p-value will fall out naturally. So let's generate our p-value here. So, oh wait, so what was my test? My test, I went and I did a sample, and my sample gave me a proportion value. Gonna have to, p-values and proportion values are different things. I think I'll use p sub v for the p-value I generate, just to distinguish it from these things. And we got 0.41, and we had 100 of them. So what we do is we calculate the z-score, so p hat minus the proportion value, divided by pq, square root pq divided by n. Remember, the p down here is the p if the null was true. That gives us a q automatically of 1 minus p, or 0.55. So we're going to be able to get a z-score. And so I'm going to get 0.41 minus 0.45 divided by 0.45 times 0.55 divided by 100, all under the square root. Now I'm going to pop over to the calculator here. Okay, now this calculation is already here. I did this when I did the previous example, so I'm just going to pull it down and look at it here. We want to make sure our numerator is in parentheses, so the 0.41 minus the 0.45 divided by the square root of 0.45 times 0.55 divided by 100. I hit enter to that, and I have a z-score of negative 0.804033. Let's come back here and write that down. So my z-score is negative 0.8040. Well, we have a table of z-scores, and so what I'm going to want to look for is the negative 0.80 z-score on that table. And I don't have a table here on the computer. This is table 5, or table 4, in your fold out in the book. It's table 4 in the e-book. It's also in the appendix of the physical book. So I'm actually getting to my appendix in the physical book here. I wish I do not have a dock camera. My laptop died, and so some of the utilities I normally have are not working on this computer. And one of them is my normal camera. I've tried using the webcam to see this, and we can't. So we come down to negative 0.8 and across to negative 0.800. I get a probability of 0.2119. And so the probability related to the z-score is 0.2119. And so now I can compare this probability, and this would be my p-value. So PV is the probability that is associated with this z-score. And so I have a probability of 0.2119. Well, that's much greater than alpha, right? So our p-score is greater than alpha. 0.2119 is greater than 0.01. And if our p-score is greater than alpha, and you want to look in your textbook for this, then we fail to reject the null. And this is on page 356 of the book. If p is greater than alpha, you fail to reject. And so our failure to reject means we cannot switch to the alternative claim. And so there is not enough evidence to support the claim. Now, I mentally look at this as even if I don't have the critical value of alpha from a chart, I know alpha creates a rejection region. And so when my p-value is greater than alpha, it creates a larger probability space, which puts my data out here, which is the fail to reject region. So when I'm trying to remember this comparison, I put it back to critical values.